So welcome to SkillXplore live webinar series. So we'll be discussing about the main syllabus and the weightage of the subjects today. So let me start. First itself, what we have, the key point before starting to study for this UPDA exam, that is Urban Planning and Development Authority and municipality and class, is that we have to study smart and not hard. As given in the first slide itself, we have to study smart and not hard. The thing is, the syllabus is actually a vast syllabus, but we need not study every nooks and corners of that syllabus. That is, we need not study the derivation part and all those theory parts and all those completely we need not study. We have to identify the highlighted areas of each syllabus. That is, in which area the repeated questions asked. That we have to understand first, and then we have to start. And in that areas, we have to completely understand the concept behind each of those areas that we have to understand. And then what are all the important formulae? If at all, if it is a problematic area, then what all formulae are there in that? Next thing we have to understand is the main point is that where all the repeated questions are asked, what all are the repeated questions, and the previous year question papers we have to solve. So more and more amount of questions we are solving, it is more easy to crack the examination. That is the key point. So we need not study hard with all those things and all. We have to first form a timetable, or else we have to first form a schedule in which area we have to stress more, for which subject we have to give our energy more. That we have to understand first. Then we have to start. So that is the point we start the preparation of the exam. So okay, SkillXplore is an interactive online tutoring platform where experts provide customized UPDA MMUP exam preparation course to Qatar engineers over the internet to crack UPDA MMUP exam in first attempt with success formula. So what we are doing is we actually customize our complete classes according to the schedule or the syllabus of this particular examination, and the stress according to the weightage of the area, the weightage of the subject. We are actually scheduling our classes, and with all areas we have to highlight as year be highlighting that, and accordingly we are actually preparing our schedule or preparing the whole classes. So that is how we actually take the training. So first we'll meet the SkillXplore experts here. So we have like 6 experts here. The first is Mr. S. Mukunda Prabhu. He has got his BE and he took his MS from London, and currently he's pursuing his PhD in NIT Tiruchirappalli. He is the project management expert of SkillXplore, and he is currently the assistant professor of SRM University, India. And next expert is Mrs. S. Shivagama Sundari. She has got her BE and MS from London, and she is also currently pursuing her PhD in NIT Tiruchirappalli itself. And she is the structural analysis expert, and she is also currently the assistant professor at SRM University, India. Next is Mrs. M. Dibya. She has completed her BE and ME, and she is currently pursuing her PhD in NIT Tiruchirappalli, and she is our geotechnical engineering expert, and she is as I've already mentioned, she is the doctoral research scholar at NIT Trichy, India. Next is me, myself, and I have completed my BTech and MTech, and currently I'm pursuing my PhD in transportation engineering and management in NIT Tiruchirappalli, and I'll be dealing with transportation engineering project 4 years, and I am currently the doctoral research scholar at NIT Trichy, India. And next is Mrs. M. Neerajakshi. She has completed her BE and ME. She is our environmental engineering expert, and she is from Tyagarajar College of Engineering, Madurai, India. And finally, Mrs. Niraimati. She has completed her BE, and she is our hydrology expert, and she is actually trained specifically for competitive examination preparations, and she is a competitive examination professional here. So now we'll move on to the subjects which we have to deal in our examination, that is UPDA MMUP examination. So what subjects we consider here, according to their syllabus, we have to study earthquake and earthquake, construction materials, structural analysis, soil mechanics and foundation, fluid mechanics, traffic engineering, surveying, environmental engineering, contracts, project management, and hydrology. All these subjects we have to cover for our examination point of view. So now we will see the weight of these subjects. So we have to identify which all subjects we have to stress more and study. So for that, we have to understand the weight of these subjects. The first is construction materials. From that, around 2 questions will be coming. Then structural analysis. From that, around 5 questions will be coming. Then soil mechanics and foundation. In that, around 3 questions will be there. And fluid mechanics, around 2 questions will be there. Traffic engineering, actually it is not traffic engineering as such, it is a complete transportation engineering, transportation and traffic engineering thing. It is not traffic engineering alone. From that, there will be almost 3 questions. Then environmental engineering, there will be almost 2 questions from there. Surveying, almost 2 questions will be there. Contracts, almost 1 question will be there. Hydrology, almost 1 will be there. Project management, almost 4 questions will be there. And RCC and earthquake, there will be almost 2 questions. So from this table itself, we can understand which subject we have to stress more, right? We have to stress more for structural analysis part, because most of the questions, that is more number of questions is coming from that area. Almost 5 questions will be coming from structural analysis part. So the first weightage that we have to give is for structural analysis. And the second weightage, as from the table itself, we can identify that second weightage to the project management subject. In that, almost 4 questions will be there. And the third portion, or the third weightage that we have to give is for soil mechanics and foundation and traffic engineering. For both these things, for both these subjects, from each of these subjects, almost 3 questions will be coming. So first weightage for structural analysis, second weightage for project management, third weightage for soil mechanics and foundation and traffic engineering. So it doesn't mean that we don't have to study all the other subjects. We have to study all the other subjects also, because in order to crack the examination, we need to cover all the subjects. But I'm just mentioning that most of the questions will be coming from these core subjects. That's all. Next is, we'll see the percentage of the questions. The same thing, it is actually given here as percentage. That is, the first is structural analysis. As I've already mentioned, 19% of the questions will be coming from that. Soil mechanics and foundation, almost 11% will be there. Fluid mechanics, 7% of the questions will be from fluid mechanics. Traffic engineering, not traffic engineering, actually transportation engineering, it will be there. Almost 11 questions will be there. Environmental engineering, almost 7% of questions will be there. Then surveying, almost 7% will be there. Contracts, almost 4% will be there. Hydrology, almost 4% will be there. And project management, almost 15% will be there from project management. So here again, I'm stressing that we have to give more weightage for structural analysis. Second weightage we have to give for project management. Third weightage we have to give for traffic engineering and soil mechanics and foundation together. Okay, you have to learn all the other subjects as well, but stress these subjects more. That's all. Okay, now moving on to the subject which I am dealing with. I'll be dealing with your traffic engineering and roads portions. So I'll just give you a glimpse of the areas which we'll be covering in our training sections, and what all areas we'll be stressing, and what all things we'll be discussing in our classes, and what all types of problems we'll be discussing in our classes. In the end of the session, I'll also introduce you to some of the previously asked questions in your specific examples, UPDA MMUP examination. So, by the end of this presentation, you will be getting a general idea about traffic engineering and roads syllabus, and also the type of the question that you can expect for your particular examination. So we'll move on. First, that is traffic engineering and roads topic. We know that there are different modes of transportation in our world. There are like air transportation, then water transportation, land transportation, etc. The mostly used kind of transportation is obviously the land transportation. The land transportation can also be divided into many actually, and the mainly actually road transportation, and the second one, that is railway transportation. So But if you are asked which one is the most flexible kind of transportation, the answer will be road transportation, right? Because almost most of our population will be preferring road transportation. Why is it like that? Because road transportation will give you like door-to-door transportation. So it is more flexible. That is why it is more preferred. So it is the most preferred mode of transportation. So in your examination, UPDA examination also, they are giving more focus to the road transportation system. So more questions will be coming from road transportation system for you people. So that's why they have given the syllabus. They have stressed 4 areas for your particular examination. And those areas are geometric design, traffic, transportation planning, and pavement materials. Okay, so the 4 major portions that will be covered in the syllabus are geometric design, traffic, transportation planning, and pavement materials. So we'll see one by one. So what is known as geometric design? So before starting to design a highway, what all things we need to understand, or what all things we have to consider for the design? So the basic thing will be the length, breadth, and all those things. That is length of the road, width of the road. Width of the road in the sense the width of the carriageway alone will be there, and after that the width of the shoulders will be there. Actually the right of way, shoulders, and everything, the total width of the pavement will be there. So the length will be there, width will be there. And next thing will be the slope variations. So the topography will be different for different areas, right? So it may be like rolling terrain or plain terrain. So plain surface may be there, then rolling surface may be there. So hilly areas will be there. So the terrain will be different. So that will be a consideration. And the various other considerations are the curves, horizontal curves. If there is any curve in our road, can we give abruptly the curve? It is not given abruptly. No, some transition is given for any particular curve. So if it is given abruptly, then accidents may occur. So that has to be considered. Then speed of the vehicle, design speed, which speed we have to design, that will be there. Where there will be some friction in the pavement, is the friction necessary? And we actually expect a smooth pavement, right? Is friction is necessary for the pavement? And if necessary, what is the range of friction? All these things will come under geometric design. So it is a vast area, and actually it is kind of the most important area in your examination point of view. The second thing is traffic engineering. As the name suggests, we'll be studying the traffic characteristics of the pavement. What is meant by traffic characteristics of a pavement? Traffic means how many maybe the capacity of the roadway, how many vehicles can be accommodated by that particular roadway, and what is the design capacity of the pavement, and also what is the actual capacity of the pavement, that will be there. And the speed of the vehicle, in the sense spot speed at one particular point. What is the speed of the vehicle? It is not like design speed, it is the actual speed of the vehicle. What is the spot speed there? That will be analyzed there. And many other characteristics like traffic signs, which all signs are necessary, and that will be there. And also various intersections will be there. No, maybe diamond kind of intersection, or clover leaf kind of intersection. Which intersection is better? What is the advantage of these intersections, and what are the disadvantages? And actually intersection and all those things will be coming under traffic engineering. And then next is transportation planning. Transportation planning, in the sense, as the name suggests, it is kind of a planning of the transportation system. So planning in the sense, in which aspect we have to plan a transportation system. There will be like various kind of trips will be there. No, something will be resident home-based trip. Home-based trips maybe if one person is traveling from home to office, that is a home-based trip. And if one person is traveling from office to home, that is also a home-based trip. So if it is for office purpose, if it is for home purpose, and in which mode he is traveling, that person is traveling. Is he traveling through a bus, or why he is choosing that mode? All these things will be coming under transportation planning area. And next one is pavement materials. Pavement materials means, the major pavement materials used are, what are the major pavement materials used? It can be like water, aggregates, and cement, right? These are the major pavement materials, and other thing is like bitumen and all those things are also added. So anyways, the main pavement materials, if we are considering, if we are considering mixed use for pavement, any concrete or pavement materials means water, aggregates and water, aggregates and cement, and that is in the case of concrete pavements. In case of flexible pavements, we'll be considering the bitumen as well. So all these things we have to study the characteristics and the test of these materials and all those things. And this test and all those things will be covered under construction materials portion. And here we'll be giving only the general glimpse of that area, which all pavement materials are used for our for constructing a pavement, and what all are the layers of pavement. Flexible pavement will not be same as that of the case of rigid pavement. Like the layers will be different. Like right. If for a flexible pavement, the top surface will be covered for bitumen, covered with bitumen, and the concrete pavement, it will be different. So what are the layers and that is like subgrade, subbase, base, and the surface course, and all these things will be covered under pavement materials. So these are the things we cover under the major 4 heads for transportation engineering are geometric design, traffic, transportation planning, and pavement materials. So that's that. And we'll see what all things are covered under each head. So the first thing, the first major and vast topic is highway geometric design. So first, before starting the design of the highway geometric characteristic itself, we have to understand which all characteristic will be affecting the geometric characteristics of the pavement, which all factors will be governing the geometric design of highways. So as you can see in the slide, the major factors that affects the geometric design of highways are design speed, topography, traffic factors, design hourly volume and capacity, environmental and other factors. We'll see one by one. I'm not giving the complete lecture here. I'm just giving the areas which we'll be covering in our classes, and how we'll be covering in those areas, how we'll be covering these portions only. I'm just briefing you. So why we are considering design speed as one of the factors governing geometric design. The first thing, actually design speed is the most important characteristic design. So why design speed is important? While we are considering a pavement, the different vehicles will be there. Each of the vehicle may be traveling in different speed. But there will be a minimum speed of the vehicle. There will be a maximum speed a vehicle can attain. So can we design the pavement with a minimum speed? No, we cannot design the pavement for maximum speed as well. It will be mostly uneconomical. So we'll be considering which speed we have to consider for designing the pavement and why. That is what is discussed under design speed. And design speed for different kind of pavements. For expressway, the design speed will be something. For an NH, the design speed will be something. So all these things we'll be discussing in detail under design speed factor. Next is topography. The topography of different areas will be different, right? Some areas it will be like the slope will be varying or gradient will be varying. Some areas it will be plain, some areas it will be rolling. So all these things will affect the geometric design of highways. Traffic factors will also affect. Traffic will be different in different regions, right? Some areas it will be residential, some areas it will be industrial, in some areas it will be like more IT firms and all those things. The traffic will be there, more offices will be there, central business district. At that area, the traffic will be very high. So the traffic density and all those characteristics we should also be considered while designing a geometrically designing the highway. So that is one major characteristic. Then design hourly volume and capacity. What is the maximum capacity of the pavement? Should we design the pavement for the maximum capacity? No. And why? What is design hourly volume and why is it more important for our exam point of view? So that all those things we'll be discussing. All those things we'll be discussing. And next is environmental and other factors. Environmental and other factors, that also varies. Like in certain areas, the rainfall will be more, right? If the rainfall is more, it will affect the drainage of the pavement. So why is it like that? So in the more rainfall areas, the design will be like some way. and how much slope we have to provide, and all these things will be, there will be some specification. If the rainfall is less, there will be some specification. The temperature affects the geometric characteristics while designing. So all these things play an important role, and these are some of the factors which governs the geometric design of highways. Each and every factors we will be studying in detail. So that is the first portion that come under geometric highway geometric design. And the second thing is highway cross-section elements. First thing is friction. We always expect our pavement to be as smooth as possible, right? But should the pavement be extremely smooth? What happens if the pavement is extremely smooth? That we have to study. And if extremely smooth, of course, the vehicles will skid and accidents will occur, right? And if the friction is more than desired, what happens? Again, accidents may occur. So what is the desirable friction level, and why are we choosing that as a desirable friction level? That is something we have to ponder on. So that is one thing. And pavement unevenness, same as that. We expect an even pavement, right? But how extent our pavement should be even, and if unevenness is there, in what extent the unevenness is acceptable, all those things we will study. Then light reflecting characteristics. What are the light reflecting characteristics of the pavement? Light reflecting characteristics, if the pavement is more light reflecting, what are the negatives? And it actually affects the night travel more, right? So all these things are highway cross-section elements. These also will be covering in detail. And next is cross slope or camber. You might be knowing what this cross slope and camber, right? So while we are designing a pavement, is it actually very smooth? No, right? Smooth in the sense very plain? No, right? It is not as plain as possible. If it is plain, what happens? If there is some rainfall, what happens? The water may be retained in that itself. There is no way for water to move away from the carriageway, right? So it will be sustained or retained in that pavement itself. What will cause that? What happens if it gets retained in that area? Some depressions or distresses or something will occur on that surface of the pavement. And yeah, so the distresses will occur on the surface of the pavement. So that is one negative. To avoid that, and that is one negative, and this water also enters to the lower layers of the pavement, and it will get retained, and the strength of the pavement get reduced. So all these things will get affected. And so to avoid that, we have to provide a slope for the pavement. So right from the starting itself, that is right from the consumption of the pavement itself, how the pavement is constructed itself, the concept of camber was there. For example, the initial times, that is the from the Assyrian Empire itself, the road was started to construct. The first is actually by the pioneers of road construction, that is Romans. They have constructed Appian Way. In that Appian Way, what they have they have done is they dug the pavement to some depth, maybe like 0.75 to 1.2 meter depth, and they have filled it with big stones, and they have leveled it. So there was no slope there. At that time itself, they understood that if water is entering, if there is no slope there, then water will enter to the lower layers, and that causes problem. And also it was uneconomical, because at that time, those times, vehicles were not there. More vehicles weren't there. So this much thickness of pavement is not required. So after that, for Tresagway construction, Metcalfe construction, then Telford construction, and the latest and the most recent one, that is the macadam construction, all those people, they have considered the camber for their construction. So for the camber itself, the first Tresagway construction, they have considered the slope for only the surface layer. They didn't give the slope for the subsurface or the subgrade layer. So at that case, they identified the problem that if we are not giving the slope for the subgrade layer, then that causes some problem. So step by step, they have identified the concept of this camber right from the initial time itself. So that itself, so we can understand how important the camber is. So the camber can be provided in different shapes, right? It can be in parabolic shape. It can be like straight line camber, and it can be a combination of a straight and parabolic type camber. So which one is better? And why do we prefer all these types of shapes of camber? All these things are discussed in our sessions. And the formula is different for each of these things. Parabolic, you can see here 2x square divided by NW, and 1 in N is the slope and x is the distance, and 1 in x is the slope. And here you can see the formula. So first we'll introduce you to the shape of the pavement chambers for different shapes of the chambers, an important formula here, and the recommended values for different type of the pavements, and some practice problems will be introduced in our sessions. And next is highway geometric design. Next portion is the width of the pavement or carriageway. Width of the pavement means, as we have already mentioned, the width of the pavement may be like the width of the carriageway alone, then the width of the roadway or the formation completely, and then right of way. All these things we have to study in detail. Some example is recommended land width for different classes of rural roads is given here. So NH and SH open areas normal range is 40, plain and rolling terrain open areas normal range is 45, and range is actually 30 to 60. So all these things we have to study. We have to actually study all these things. These may be there in your examination as well. So then it's cross section of the roads. That is one important portion. That is the cross section of the roads, and that will also be introduced here. Here also we can see the cross section of different kinds of roads. First is other district roads, and next is rural area roads. That is major district roads, and the last one is national or state highway roads. All these things will be discussed in detail in your sessions. And next important point is side distance. In this area, repeated questions are normally asked. That is, the major three side distances are stopping side distance, overtaking side distance, and intermediate side distance. Stopping side distance. First we will see what is side distance itself. Side distance means if you are traveling in a pavement, and how much amount of distance is visible in front of you, or safely stopping the vehicle. That is known as stopping distance. That is, you are traveling in a pavement. Any driver is traveling in a pavement. Some obstruction he is seeing from here. It is visible for him. So if he is traveling, what is the safe stopping side distance between that object and the traveling vehicle, so that collision will not occur before him stopping it. So that is what is known as stopping side distance. Before him stopping the vehicle, how much distance is there so that this vehicle will not collide with the upcoming obstruction. So that is studied in the stopping side distance. This can be like when the driver is just seeing the obstruction there, it will take some time for him to understand that an obstruction is there, and you have to apply the brake so that you won't collide. So that time is known as lag distance. That itself is divided as perception, intellection, emotion, and volition. Perception means something is there, he is identifying, and intellection means it is actually the senses is sent to him, and he is understanding that you have to stop it. Then emotion means there might be some emotions such as anger or stress or something like that. So the time spent for that. And volition means the time actually he takes to apply the brake. That at that time the vehicle will be traveling in the speed in which it was already traveling. So that is known as lag distance. And after he perceives, he applies the brake, the vehicle will also travel for some amount of distance. That is known as braking distance. So the stopping side distance itself is divided into lag distance and braking distance. So stopping side distance is a combination of lag distance and braking distance. There is a different formula for lag distance and different formula for braking distance. So the total stopping side distance will be the sum of these two. So that itself is we have to study. Same overtaking distance. How much distance should be there? It should be there in between your vehicle, the vehicle you are driving, and the vehicle which you are expecting to overtake, so that there won't be a collision between these two vehicles. That is known as overtaking side distance. Here, more number of things we have to consider. You are traveling in the design speed, or the speed which you are expected to travel in that particular road, and maybe the vehicle in front of you will be traveling in a lesser speed. So you are trying to overtake that lesser speed vehicle. So in that case, you should, while you are reducing the speed also, you shouldn't collide with the vehicle incoming overtaken vehicle. And while overtaking the vehicle, you are changing the lane, right? You are changing from one lane to other lane. So then only you can overtake. While you are changing the lane, the vehicles may be coming from the opposite direction. It will be traveling in another speed, or maybe the sign speed itself. So you shouldn't collide with that vehicle. So that also you should consider. And after you are passing the distance, overtaking distance, then you have actually crossed the, again, there is a lane change. You have to come back to the original lane itself. At that time, you shouldn't collide with the already overtaken vehicle. So all these things are considered in the overtaking side distance. So a set of formula and the combination of the formula is there for overtaking side distance that you have to study. And these are some important portions under highway geometric design. Next is intermediate side distance. Intermediate side distance means in certain areas you can't provide the complete overtaking side distance and all. In that case, we'll just take the double of so stopping side distance and provide. So all these things, the concepts, the important formulae, the problems, all these will be discussed under our sessions. Next is next important portion is super elevation. So what is known as super elevation? You are traveling in a road, and you are seeing a horizontal curve there. And while you are traversing that horizontal curve, the centrifugal action will be there, no? So some due to the centrifugal force, there are chances that the vehicle may overturn. That is, the vehicle may topple due to the effect of the centrifugal action. What can be done to tackle this problem? So for that, we can actually raise the outer edge of the pavement to some extent so that we can counteract this centrifugal force. And that raising is known as super elevation. So there will be a set of formulae for super elevation. And so we have to study the concept, important formulae and problems in that area as well. Here also we can expect some repeated questions from super elevation. Another thing is the radius of the horizontal curve. What should be the radius of the horizontal curve so that there won't be any problems while encountering the curve? So there will be a minimum radius, there will be a maximum radius, there will be a grade compensation. All these things will be studied under this radius of the horizontal curve. So concept, important formulae and problems in this area will also be discussed in our classes. Next is widening of the horizontal curve. Okay, while we are encountering a horizontal curve, will the width be the same as that on the other roads as well? No, right? Some widening will be provided in the horizontal curve. Why do we provide that widening? There are actually many reasons for providing, actually mainly two reasons for providing the widening. It can be given for a mechanical widening reason and psychological widening reason. Mechanical widening, that is when a four-wheeler or six-wheel vehicle, not a two-wheeler vehicle, is negotiating a horizontal curve at relatively slow speed, the rear wheels, that is, there will be two sets of wheels will be there, no? The rear wheels will not raise the same path as the corresponding front wheels. There are chances that this rear wheels will go out of this width of the pavement while we are encountering a curve. To avoid this, we will be giving extra width to the pavement. That is known as mechanical widening of the pavement. We can provide this width to one side alone, or we can provide it, we can evenly distribute to both sides. Where all we provide it for one side alone, where all we split this width in two areas. All these things we have to study. In psychological widening thing, that for extra safety, these drivers will have a tendency to move to one edge while encountering a curve. In that case, it also we have a at that case also there is a possibility that maybe one wheel may go out of this pavement width. In that case also, so a widening is required. That is kind of psychological widening. So two sets of two formulas there for mechanical and psychological widening, and how the problems will be coming in these areas. These things will also be discussed in our sessions. So the concept, important formula and problems here as well. Next is transition curve. We have already mentioned, right, while we are encountering a curve, we can't just abruptly put a curve somewhere. So we have to give a proper transition there. We can't give like straight road, curve, and then straight road. We can't give like that. We have to transition the curve. How we are transitioning the curve, what are the functions and what are the types? There are actually different types of transition curves, the different shapes for transition curve. Why do we provide different shapes for transition curve? where all these types of curves are provided, what are the advantages, what are the disadvantages, and also important point, the length, which are how much the length. Here we can see the transition curve in the figure. So what is the expected length or desired length for this transition curve and its problems? All these things are considered here. And next is the setback distance and clearance distance of the horizontal curve. So some setback distance or clearance distance should also be present in the pavement for while encountering a horizontal curve. What is the concept and why? What are the important formulae here? And what are the problems coming under that? Curve resistance. All these things will be discussed. Next is we'll see what is setback distance or clearance distance on horizontal curves. In the design of horizontal alignment, the side distance along the inner side of the curve should also be considered. As we have already mentioned, side distance is important. So when there are slight obstruction like buildings, cut slopes or tree on the inner side of the curves, either the obstruction should be removed or the alignment should be changed in order to provide adequate side distance. So here also the key is side distance. To provide adequate side distance, some changes should be given in the alignment. So that is actually known as the setback distance or clearance distance. It actually depends on the factors like required side distance, radius of the horizontal curve, length of the curve. It may be greater or less than the S. What is S? Here the S is the side distance. Here we will see some practice problems here at the end of the presentation itself. There we can see what is this SY, how the formula is considered, and all these things we will see. So it depends on these factors. Next is design of the vertical alignment. Vertical alignment itself, there are actually summit curves, valley curves, many things are there. Gradients, as we have already discussed, there will be like 3 types of gradients. Ruling gradient will be there, limiting gradient will be there, exceptional gradient will be there. How are these gradients, how these gradients differ, and what is the expected range of gradients for different kinds of roads, and all these things we will discuss. Then that is actually gradients for roads in different terrains. All these things we'll discuss. Then summit curves and valley curves. What are summit curves and what are valley curves? Summit curves, anyways, there will be, as in the case of horizontal curves, there will be vertical curves also. Horizontal curves means horizontal curve, horizontally on 2D areas, and summit curves and vertical curves means vertical curves like. If the curve is convexity upwards, then summit curves. And if the curve is actually concavity upwards, then that is valley curve. So all these things will be there. And in summit curves itself, there are a set of formulae. It is also an important area. There will be a set of formulae. That is, in summit curves, we have to check whether the length of the summit curve is less or greater than stopping side distance. So, and again, the length of the summit curve should be what length of the summit curve is given for overtaking side distance and intermediate side distance. All these things will be discussed separately. Then valley curve, again, the length of the valley curve for comfort condition and length of the valley curve for headlight side distance condition. All these things we'll address separately, and the concept, its important formulae and problems. All these things will be addressed one by one. Okay, next is traffic. Next important point is the traffic region, traffic engineering. Traffic engineering means what are the traffic characteristics of the pavement. There are many basic terminologies for traffic engineering. So for example, there will be like capacity itself. I'll give you just a glimpse of the capacity area. Traffic capacity itself we can study in different levels. That is what we might know what is traffic volume and traffic capacity. The general two phrases we might know. The first is the traffic volume. Traffic volume means the number of vehicles moving in a specified direction on a given lane or roadway that pass a given point or cross section during specified unit of time. Just that a number of vehicles passing a particular point at a specified unit of time. That is known as traffic volume. And traffic capacity means the ability of the road to carry the number of vehicles. That is known as traffic capacity. So these two things we might know. Traffic volume, number of vehicles passing a particular point, and traffic capacity, maximum amount of vehicles that a road can carry. And there are new terms like basic capacity, possible capacity, practical capacity, etc. we need to understand these areas as well. For example, basic capacity is the maximum number of passenger cars that can pass a given point on a lane or roadway during 1 hour under the most nearly ideal roadway and traffic conditions which can possibly be attained. That is number of vehicles that pass a particular point of time in 1 hour in most ideal condition. We cannot design a pavement for basic capacity. We cannot expect a pavement to be in its ideal condition, but we have to understand what is the basic capacity of that pavement. And the another thing is the possible capacity. Possible capacity also the same thing, the maximum number of vehicles that can pass a particular a given point on the lane of roadway during 1 hour, same as in the case of basic capacity. Here the key point is it is actually for the prevailing roadway conditions, not for ideal roadway condition. So this is more practical. But what is practical capacity? Again, it is not possible capacity. Practical capacity is different. It is the maximum number of vehicles that can pass a given point on a lane or roadway during 1 hour without traffic density being so great as to cause unreasonable delay, hazard, or restriction to the driver's freedom to maneuver under the prevailing roadway and traffic conditions. So this is actually the most practical way to put the capacity. So mostly while we design a highway, we'll consider the most practical way, that is the practical capacity. So for one single term capacity itself, there are this many number of subdivisions. So those comes under the traffic engineering. So next is static characteristics and dynamic characteristics. Static characteristics without moving and dynamic characteristics while moving. So all these things we have to study step by step. Then dimensions of different vehicles. Why do we have to know the dimensions of the different vehicles? While designing the pavement, while width of the roadway and all those things, the traffic, the dimensions of the vehicles come into play. So in rural areas and all, more number of trucks and all will be there in those areas. And in those areas, while we are designing a pavement, we have to know the width of the vehicles which we can expect in that area, right? And also while we are designing an underpass or overpass, there will be like roof in the underpass. While we are designing a tunnel and all those things, there will be roof, no? So height of the vehicle come into play there. So the dimensions of the different vehicles we have to understand. Then other traffic flow fundamentals, that is many other things which are also considered here. Headway distances, spacing between the vehicles, all these things will be discussed. And levels of service. Levels of service is another important portion, and I have seen some repeated questions from this area. For levels of service, it is actually a qualitative analysis of how freely a vehicle can maneuver in that area. So for that, the roads are divided into 6 classes, that is level of service A, level of service B, level of service C, level of service D, level of service E, and level of service F. I have actually included a glimpse of that area in the upcoming slides. We'll see how it is divided, and all these things we'll be discussing. Next is traffic volume study. Traffic volume itself, as we have seen in the capacity portion, traffic volume also can be divided into different ways. Do we have to design our do we have to design our pavement for the maximum volume? No, then it will be uneconomical. So we have to find out some kind of attribute, some design and average annual daily traffic, or some kind of traffic we have to consider for the design purpose. And which one is more apt for design purpose, and why have we selected that? There are many kinds of traffic volume study, that is traffic volume, design hourly volume, average annual daily traffic, average annual weekday traffic, and all these things actually average daily traffic, average weekday traffic, peak hour factor. All the peak hour factor and all repeated questions come under this peak hour factor problems. Here also the concept, formula, and important problems we'll discuss. And we'll see what is this level of service alone is introduced, how this level of service alone is introduced. We'll see how it is done. The first is the level of service A. Level of service A means that here in the figure itself, we can see that there are not much traffic. The vehicles can maneuver in whichever way they want. So the traffic flows or above are flows in or above the posted speed. So complete mobility between the lanes are there. So such a level of service is known as the level of service A. It occurs late at night in urban areas and frequently in rural areas. Then level of service B. Here we can see some more vehicles are there in the road. So it's actually a reasonably free flow, but we cannot say that it is completely free. So the traffic stream is slightly restricted than level of service A. Here motorists still have a high level of physical and psychological comfort. And next comes the level of service C. Here some more vehicles are there, but here also a stable flow at or near the free flow is there. So here the lane changes require more driver awareness, and most experienced drivers are only comfortable here. And this is the target LOS for some urban and most rural highways. And level of service D, more vehicles are present. So it is kind of approaching the unstable flow. So the freedom to maneuver is within the traffic stream is much more limited. Here, minor incidents like busy stopping corridor in the middle of a weekday or a functional urban highway during or commuting hours, all these things could be expected. And next is final two, that is the level of service E and level of service F. In level of service E, we can see that it is actually unstable flow. So it is not completely in a stopped condition, but still it is nearing the stopped condition. So here the flow becomes irregular and speed varies rapidly. So any incident will create serious delays. Driver's level of comfort becomes poor. And level of service F means forced or breakdown. That is, the vehicles are standing still there. So travel time cannot be predicted. And for example, a highway might be at level of service D for the AM peak hour. That's it. So in the traffic capacity study, we have already mentioned how it is done, and traffic density, traffic volume, traffic capacity, and basic capacity, and possible capacity, practical capacity. All these things we have already mentioned before. And next is traffic volume study. Here we'll see how traffic volume is studied one by one. The traffic volume we have already mentioned, and next important category is the 30th highest hourly volume or design hourly volume. So it is actually found from the plot between hourly volume and the number of hours in a year that the traffic volume is exceeded. 30th highest hourly volume is the hourly volume that is exceeded only 29 times a year. So that is actually taken for the design purposes generally. Then average annual daily traffic. So average traffic for the 365 days, that is normally taken as average annual daily traffic. It is measured by the present demand for service by the street or highway, developing the major or arterial street, etc. Then average annual weekday traffic. Here the 24-hour traffic volume is stressed here. Then average daily traffic. Here the given location for some period but less than a year is considered. Then average weekday traffic, here on weekdays alone for some period of year less than a year, such as for months or a season. So everything is different. Then peak factor. Peak factor, we'll see a problem also in the upcoming sessions, in the upcoming slides. Here the peak factor is typically calculated from the traffic counts. So traffic counts. So it is the average volume during the peak 60-minute period. So this we will be learning more in the upcoming problem. So at the peak 60 minutes, what is the maximum traffic we can expect? Divided by 4 into maximum 15 minutes traffic we can expect. So if we are dividing the traffic into like 16 minutes, what is the maximum traffic we can expect there? And we are dividing it into 15 sections. What is the maximum 15 minutes traffic we can expect there? So 60-minute traffic divided by 4 into 15 minutes maximum traffic is known as the peak factor. I have seen like more than 4 or 5 times they have asked the peak factor questions alone. So in your examination. So that is one important thing. And for if it is not like 15 minutes, we can also change the formula. Like for if they are asked for like 5, 10, 20 minutes, so you can change the formula accordingly. Instead of 4, you can give like 60 divided by n. N is the number of minutes they are asking. So the formula can be changed as well. So you have to check the problems or the questions, how they are given. They might not always ask 15 minutes itself. So that you have to check. Then next to speed study, spot speed study. At a particular point, what is the speed of the vehicle? That itself we can say. Then average speed of the vehicle. That itself we can study in 2 different ways. That is space means speed and time means speed. Those 2 things, that is one major portion. the running speed, overall speed or travel speed, all these things we have to study. The types of speed studies that as I have already mentioned, you have to speed area, spot speed, and spot speed we can study, and also the speed and delay can also be studied. Then important relations, repeated questions have also come from this area, that is the speed density relation. As speed increases, we know that density decreases. So this graph they'll give like four graphs, and they'll ask you to choose which is the right one. Then volume density relation. Here you can see as flow increases, the density increases up to a particular point and then it decreases. Why? That we have to address. Next is, what is the relation between speed and volume? That we have to address. Then origin and destination study. Why are we studying origin and destination? We have to understand, we have to find out the expected traffic there. So that is origin and destination study. Then what are the methods used for collecting this origin and destination data? Then how we can present this origin and destination data? We normally present the origin and destination data by the desired lines plotting. That is according to the number of traffic, we plot lines between our starting point and end point. If the number of traffic is increasing, the thickness of the desired lines will be more. So that is one method for presenting the origin and destination data. So that one. Then relationship between the speed, travel time, volume, density, capacity, as we have already mentioned, that will be there. Then conflict points. That is one major thing. What are the conflict points? While we are traveling on a pavement, there will be like many conflict points. While if we are crossing a point, then there will be a conflict. And if two ways are there, and if it is merged, then there will be a conflict there. And while we are diverging, if two ways are there and it is getting diverged, then there will be some number of conflicts. So that we have to study in detail. So for example, with an example figure itself, we'll show you how the conflicts will be there. For example, if there are two roads, road A and road B. Road A has 2 lanes. Road B has again two lanes. Then number of potential conflicts. How many types of conflicts can arrive there if both these roads, that is road A and road B, are two-way roads? That is, road A has 2 lanes, road B has 2 lanes. Both these are 2 ways. Then we can expect 24 number of conflicts. If road A is 1 way and road B is 2 way, then the number of conflicts will be reduced from 24 to 11. And if both roads are 1 way, obviously number of conflicts will be less. 6 number of conflicts alone will be there. So all these things we will be studying. For example, on a right angle road intersection with 2-way traffic, and the total number of conflict points are 24. As we have seen here, right angle 2-way traffic, total number 24. So this actually consists of 16 crossing conflicts, which are the major conflict points. The merging and diverging conflicts are considered as minor conflicts, numbering 4 in each case. So 16 plus 4 plus 4. 4. That is how this 24 conflicts have arisen. So like that, if we are changing the question, maybe like there are 2 roads and both these are 4-lane roads, and one is 1 way and one is 2 way. So how many number of conflicts we can expect there? So options will be option A 24, option B 17, option D C 8, and option D 25. You have to rightly choose option D. We cannot sit and draw each of these conflict points, and we cannot count how many conflicts have arisen there. So this table is actually very, very important in your exam point of view. So that will be there. We'll discuss that. And then intersections. Intersections also, there will be like horizontal intersections and there will be like grade intersection. In each of these will be addressed separately. Horizontal intersection, if it is grade separated intersection, then there will be underpass, then overpass, trumpet interchange, diamond interchange, cloverleaf interchange, partial cloverleaf interchange, and directional interchange. One by one, we'll address all these intersections. And we also see at which areas we'll be giving these kinds of intersections. Why do we give these kinds of intersections? What are the advantages and disadvantages of each of these intersections? We'll address all these things one by one. Next is at grade intersection. It can be three ways. Channelized one. We'll be giving a channel, and we'll be providing channels, and we are asking them to follow that particular channel. So channelized intersections will be there. In some areas, it will be unchannelized intersection, and finally rotary intersection. All these three will be discussed separately, including the advantages and disadvantages. Next important portion is the levels of intersection control. Also, there are actually three levels of intersection control, which will be passive control, semi-control, and active control. So all these three things will be addressed one by one. So passive control, it will come like no control, traffic signs, give way control, two-way stop control, all-way stop control, traffic signs plus marking. All these things will come under passive control. Next is semi-control. As we have already discussed, it will be like channelization and traffic rotaries. All these things will be coming under semi-control. And the third thing is active control. Traffic signals will come under active control. We can see here different kinds of traffic signals, and they might ask you like one figure. They'll give one figure, 4 figures they'll be giving you, and you'll be asked to choose which one is give way sign, and what is the dimension of that give way sign. All these things might be asked. For example, for stop sign, it is intended to stop the vehicle, as you already know. And it's octagonal. Here we can see the stop sign. It is octagonal in shape, red in color, and white border. That is how stop sign is given. And the sign may also contain stop, that letter stop written in English or any other languages as preferred, as necessary. That is about stop sign. Again, give way sign. Give way sign is used to control the vehicles on a road so as to assign the right of way to the traffic or other roadways. So this sign is actually triangular in shape and with an apex downwards and white border. So all these things we have to understand. So it will be in white color with red border. So this is actually apex downwards, not apex upwards. So 4 options will be there. It might get confused. So all these things we have to study separately. So these things will be addressed. And next is transportation planning. So that is about traffic. So we have covered what all things we'll be covering in geometric intersection, geometric characteristics of the pavement, then traffic, and third one is the transportation planning. The transportation planning, actually, the main things are divided into 4. That is trip generation, how it is generated, and how it is distributed. That is trip distribution, then mode choice, which mode is chosen, and finally the trip assignment. These 4 things are considered for major things. That is the transportation planning. Then next is zoning. Zoning means how the areas can be divided as different zones, like the zones for residential area, zones for industrial area, zones for other business areas. So zones have to be divided for each areas. So what all criteria we have to consider while zoning. All these things we'll be considering. Then additional portions are also considered, such as road user characteristics and car line models. These are actually introduced here because we have seen previous year questions from these areas. So we have also included these portions here. That is pipes model, FOBS model, general motors model, optimal velocity model, then moving observer method. These things are also introduced because it has asked the previous year questions. And some example problems will also be discussed. For each and every sections which we have mentioned here, we will be giving you example problems just after this session. And also after completing the complete sessions, we will be giving you quizzes, and you can take the quizzes, and mock test will also be there. So finally, the pavement materials part. The pavement materials part, as we have already mentioned, aggregates will be there, bitumen will be there, aggregate bitumen mix will be there. In the case of water, for even constructing the pavements also, the water chosen, used should be potable water. What is potable water? The standards for drinking water. A drinking water, which can be used for drinking purposes, is known as potable water. So at that level, the water should be pure. So those things we'll be discussing. And desirable property aggregates can be of two types: fine aggregates and coarse aggregates. So it can, according to various, this is according to the size. Other things also, in other ways also, we can split the types of aggregates. Maybe like naturally occurring aggregates, artificially occurring aggregates. All these ways also we can split the type of aggregates. So here we'll split it as fine aggregates and coarse aggregates for our pavement construction purpose. So for coarse aggregates, we use it for strength characteristics, and fine aggregates, we use it to fill the gaps and gaps of the fill the void. What are the purposes of each of these materials, and how are these things will be addressed in more detail in the construction materials portion. And here we'll be giving just the general idea of these pavement materials. What are the desirable properties of soil? What are the desirable properties of aggregates? Then important thing, what is the difference between bitumen and tar? These are normally used interchangeable, but it is not like that. It is different. What is bitumen and what is tar? Why is it different? And then tests on bitumen. There are various tests for aggregates, various tests for soil, various tests for bitumen. All these things will be discussed. Actually, this will be discussed more in detail in the will be the idea. Then next thing is the composition of the pavement, how the pavement is composed of, and the components of flexible pavement. The components of the flexible pavement will not be the same for that of the components of the rigid pavement. Both will be different. Why is it different? And what are the layers? What are the thickness of each of these layers? All these things, along with the cross-section figures, we'll be introducing. Then typical flexible pavement failures and typical rigid pavement failures. What are the failures which we normally see on the flexible pavement? Flexible pavement is our bitumen pavement itself. So normally the bitumen surface pavement itself. So here, what are the pavement failures we normally address? There can be a variety of pavements. You'll be familiar with potholes, right? Potholes will be there on the pavement. Then raveling may be there on the pavement. Then cracking itself can be divided into two. There will be longitudinal cracks and there will be transverse cracks. Both these kinds of cracks can be seen on the pavement. And again, if both are there, these are there, and it has grown to some extent, it can be like in a alligator boat. So it will be like similar to the skin of the alligator. So it is kind of an alligator cracking, like a mesh or something. So again, it will be alligator cracks will be formed on the surface. If again it is distress, it is becoming distress, and this alligator crack will be again formed as a pothole. Will be developed to a pothole after some period of time. So that may occur. So all these kinds of distresses will be addressed one by one. And another major thing which we normally see is rutting. Rutting means when the wheel is moved over the surface of the pavement, the depression may occur along the path of this wheel. That is known as rutting, which is one of the important failures. And depressions may be there on the pavement. Depressions is not same as pothole. Pothole is different. Depression is different. Then settlement, uneven settlements will be there on the pavement. So all these things, different kinds of failures will be there on the flexible pavement. But the same for the rigid pavement failures, it is not the same. The distresses seen on the flexible pavements may not be there on the rigid pavement. It is completely different. Here the double bars will be there, and all these things, the uneven movement of these pavement surfaces will be there. So the kind of distresses which we can expect in rigid pavement is different. So we will be addressing both these with different, both these separately. So now we will see some of the previous questions. So here the initial some of the questions are from the from the exam just 1 week before. That is 1 week before these questions are asked in the previous exam. So this is the most recent questions. The first 10 questions will be the most recent questions that are asked. So we'll discuss from that. We'll start from that, and then some previous year questions will also be addressed in the upcoming slides. So first question. A driver rounds a curve at a speed of 60 miles per hour and sees a truck overturned on a roadway level ahead. How far will the driver's vehicle travel before the driver's foot reaches the brake? So the question is very clear. They are asking how far the vehicle will travel before the driver's foot reaches the brake. So they are asking before the brake is applied, how far the vehicle moves. Anyways, while braking, the vehicle will stop. So this is something related to stopping side distance, right? The vehicle moving and stopping. So stopping, something related to stopping side distance. As we have already mentioned, stopping side distance can be split into two: lag distance and braking distance. Before the application of the brake, while the driver sees the object, he'll while he is understanding that you have to apply brake, that time itself vehicle is moving, that is known as lag distance. After the application of the brake, the vehicle moves to some distance, that is known as braking distance. So the stopping side distance is divided as lag distance and braking distance. The formula is SST is equal to VT plus V square by 2GF. So how far will the driver's vehicle travel before the driver's foot reaches the brake, right? So that is, they are asking about lag distance. After the application of the brake, it will be braking distance. So before the application of the brake, that is lag distance. So from this formula, we have to separate this VT part alone. So we have to find out the VT part. So the answer is given in feet. In our question, the speed is given in miles per hour. So we have to concentrate on the units. And in what unit they are asking, you have to convert it and then give the answer. So here, only VT we have to find out. What is V? The speed of the vehicle. And what is T? T is the reaction time. If the reaction time is not given in the question, in this question, the reaction time is not given. If it is not given in the question, you have to choose it as 2.5 seconds. So you have to by heart this value. You have to choose it as 2.5 seconds. So the lag distance is this speed of the vehicle into 2.5 seconds. So first of all, we have to convert the speed into feet per second. 60 miles per hour is equal to 88 feet per second. After converting it, that value into the reaction time 2.5 gives 220 feet. So the answer is option B, that is 220 feet. So you have to you shouldn't find the complete stopping side distance and give the answer. There error can occur. You shouldn't give the answer in some miles, answering miles. There the error can occur. So you have to stress the unit, identify the unit and what they are asking separate, carefully. So we read the question well, take your time and then find out the answer. But thing is, time frame is also less. So you have to solve more and more questions. Then only you can be familiar with the pattern of the questions, and then only you can solve it fastly. So that's that. And next question, ASHTO. The abbreviation of ASHTO. This has been asked many times. So they have given 4 options. One is American Authority of State Highway and Transportation Officials, American Association of State Highway and Transportation Officials, then American Association of State Expressway and Transportation Officials, and finally American Society of State Highway and Traffic Officials. So 4 options are given. If you check the first 2 options, A and B, only one word is different. In first option, it is American Authority. And in the second option is American Association. So it can be confusing. So you have to thoroughly study the abbreviations as well. So the frequently asked abbreviations are ASTM and ASHTO. ASTM is American Society for Testing and Materials. ASHTO is American Association of State Highway and Transportation Officials. So the correct option is option B, that is American Association of State Highway and Transportation Officials. Apart from these 2 abbreviations, some other abbreviations are also found to be asked in the previous years. That also we'll be discussing in our sessions. And question number 3. Question number 3 is, if a roadway has a design speed of 65 miles per hour and the maximum values of E is equal to E. What is E? E is the super elevation and F is equal to 0.11. What is F? Coefficient of friction. The minimum radius is computed as radius. Radius is the formula for radius is V square divided by E plus F into G. The thing is, this formula gives the answer in meter per second or meter. So here the V value is in meter per second. R minimum is equal to V by E plus second to G. Here the V is in meter per second. But in our question, the answer is in miles per hour. So first we have to convert the value into meter per second. That is 29.05 meter per second. 65 miles per hour is equal to 29.05 meter per second. So first we have to convert to meter per second. Then R minimum, compute the R minimum. That is 452 meters. While we are computing, substituting this 29.05 meters in the formula, we will get the answer as 452 meters. But again, here the answer is given in feet. We have to again convert this into feet. That gives the answer as 1483 feet. So the unit plays a very important role in your questions. So to show that this question itself is here also, first we have converted into meter per second. Again, we have to convert it into feet. So the answer is that. So option B is the answer, 1483 feet. Next question that I've already mentioned, peak hour flow is a frequently asked area. So what is the maximum value of peak hour flow? And what is the minimum value of peak hour flow? Both these are asked. Maximum value of peak hour flow options are A1, B 0.35, C 0, and D 0.25. Again, what is the minimum value of peak hour flow? Option A 0.5, option B 1, option C 0.25, and option D 0.75. So these are the two questions. So we have already seen what is the peak hour flow. The peak hour flow is typically calculated for the traffic counts. The flow value, the term flow itself suggests that it is something related to traffic count. So it is the average volume during the peak 60-minute period, we average 60 divided by 4 times the average volume during the peak 15 minutes period, we average 15. We'll particularly see how it is done in the next upcoming problems. And here the limit of this peak hour flow is generally between 0.25 and 1. From this range, we can identify what is the minimum value of peak hour flow and what is the maximum value of peak hour flow. So for the first question, that is the maximum value of peak hour flow, the answer is 1. That is option A. Minimum value of peak hour flow, the answer is 0.25. That is option C. Fine. So questions 4 and 5 are that. And question number 6. Here, this is a problem. Here we can see a district road with a bituminous pavement has a horizontal curve of 1000 meters for a design speed of 75 kilometers per hour. The super elevation is option A 1 in 40, option B 1 in 50, option C 1 in 60, and option D 1 in 70. We'll see how it is done. The super elevation E is equal to V square divided by 225 into R. We can just substitute the values. V is the design speed or the speed of the here design speed. Here V it is given as 75 kilometers per hour. Substitute the value for V. Then R is given as a horizontal curve radius. It is given as 1000 meters. So just substitute the value. 75 into 75 divided by 225 into 1000. The answer is 0.025. But it is not there in the option, right? So why it is not there? They are asking in the form of how much distance for 1 meter super elevation, how much super elevation for 1 meter distance. So in that way they have asked. So 1 divided by answer is 40. So the answer is 1 in 40. So you have to check how the answer is given in the option and then you have to write it there. You have to choose the options. So answer is option A, that is 1 in 40. You have to just substitute the values, find the answer, and if it is given in this 1 in something form, then just divide the answer back from 1 and then you can put it like 1 in 40. So we have already discussed the peak factor problem. So here it is, using the following traffic counts, determine the peak hourly traffic volume and what is the peak hour factor. So here we can see the 15 minutes interval traffic is provided here. Interval 4:15 to 4:30, volume is 520, 4:30 to 4:45, volume is 580, 4:45 to 5, volume is 670, 5 to 5:15, volume is 790, 5:15 to 5:30, volume is 700, 5:30 to 5:45, volume is 630, 5:45 to 6, volume is 570, and finally 6 to 6:15, volume is 510. All these things are divided by with an interval of 15 minutes. Fine. Okay. So our question is, what is the peak hourly volume? So how can we find that? for 1 hour time period of 4:15 to through 5:15. What is that? 4:15 to 5:15. That is 1 hour. Fine. So how the total volume 520 plus 580 plus 670 plus 790. What is the value? 2560. First, you have to identify that. Similarly, for all the other 1 hour time period, what is the maximum number of vehicles or the maximum traffic volume, hourly traffic volume? That you have to identify. 4:15 to 5:15, you have to identify. Similarly, 4:30 to 5:30. 580 plus 670 plus 790 plus 700. That you have to identify. And similarly, 4:45 to 5:45, 5 to 6, 5:15 to 6:15. Here we can see the subsequent 1 hour intervals and the traffic volume of these subsequent 1 hour intervals. So from this, find out the maximum traffic volume. Here the maximum traffic volume is 2790. So that is the peak hourly volume. So that is one. Second part, that is peak hour factor. That is a repeated question that we have already mentioned. We have already seen the formula of that, and we will see how it is calculated. We now know what is the peak 60-minute traffic that we have already identified, right? 2790 vehicles per hour. That is the peak 60-minute traffic divided by 4. How we got the 460 divided by 15? We already know that V divided by 4 into V15 is the formula for peak hour factor for 15 minutes. So that's it. And next is, what is the 15-minute peak of this traffic? So here, which is the, this is for 15 minutes. This is for 60 minutes. We have identified the 60 minutes peak and put it in the numerator. And this is for 15 minutes traffic, and we have to identify the maximum traffic here. Which one is the maximum value here? Here the maximum value is this 790. So here the 790 has to be put under put in the for B15 value. So 790 divided by this 4 value, we got it like 60 divided by 15. If it is asked for 20 minutes traffic, then we have to give it like 60 divided by 20. Anyways, for normally they ask for 15 minutes, so you can by heart this 4 value, the value 4. So 2790 divided by 4 into 790. We get the answer as 0.883. Fine. So that is how peak hour factor is calculated. Question number 7. And next is question number 8 and 9. So design horizontal, for design of the horizontal and vertical alignments, super elevation, side distance and grades, it is worst affected by option A, width of the vehicle, option B, length of the vehicle, option C, height of the vehicle, option D, speed of the vehicle. Why we have started the session itself, we have mentioned that, I have mentioned that the most important parameter is speed of the vehicle. So it is the worst, which is the worst affected characteristic, that is the speed of the vehicle. Which is the most important characteristic, that is the speed of the vehicle. So the answer is option D, that is the speed of the vehicle. Okay. And the next thing, in highway work, grade is usually given in 1 is percentage, 2 is elevation, 3 is degrees, and 4 is slope. So which one is the, normally the grade is given in percentages for highways. So these are the questions 8 and 9. Next is question number 10. So in an ascending gradient of 1 in 50 meets a descending gradient of 1 in 50, the length of the summit curve for a stopping side distance of 80 meters will be option A 0, option B 60 meters, option C 80 meters, and option D is 50 meters. So here, this is actually a tricky question. Here what it is for gradients, this length of the summit curve is what is they have asked. We have to assume one thing at first itself. We have to assume, like, if length is greater than stopping side distance, we have to choose this formula, that is L is equal to N into S square divided by 4.4. What is N? Here the slopes are given, ascending gradient 1 in 50, descending gradient 1 in, the N is actually 1 in 50. The difference between these slopes, one is ascending and next one is descending. So 1 by 50 minus 1 by 50. So it is like 1 by 50 plus 1 by 50. The answer will be 0.4. no, 0.04. So that is the n. Then into s square. S is the stopping side distance, and here it is given as 80 meters. So 0.04 into 80 divided by 4.4, we get the answer as 58, approximately 60. Let it be 60. So here our initial assumption was L is greater than SST. Here we can see that 60 or 58, whatever it is not greater than the SST given in the question, that is 80 meters. So it is not the right answer. So we have to choose the second option, that is assume L is less than S. The formula is different. L is equal to 2S minus 4.4 divided by N. Substitute the values. 2 into 80 minus 4.4 divided by N, as we have already mentioned, it is 0.04. The answer is 50. So hence the correct answer here is 50. See the answer, both these answers are there in the option. Length 60 meter is there, again 50 meter is there. If we are not checking these condition properly, then there is a high chance that you will choose the wrong option here. So here the answer is actually 50 meters. So you have to check all the conditions. You have to be thorough with all the previous year question papers, so that you can find the correct answer. So these 10 questions are from the most recent examination. And next we'll also cover some of the previous year questions as well, maybe like 5 questions, and that's all. So question number 11. The speed on a road in Doha is 60 meters per hour. And the density estimated is 16 VPHPL. What is VPHPL? Vehicles per hour per lane. That is VPHPL. The approximate flow rate on that section. It is a very simple question. Flow rate means speed into density. They have given both these values. Just substitute 60 into 60. We will get it as 960 VPHPL. VPHPL is vehicles per hour per lane. Directly option C. So this is a very simple question. They have asked it once. Next is ASHTO recommended perception and reaction time for stopping side distance. While we have discussed the stopping side distance problem itself, we have it was mentioned like if this reaction time is not provided, choose it as option C. Choose it as 2.5 seconds. So here it is actually option C. 2.5 seconds. So whenever, even in the problems, if they have not specified the reaction time, you have to choose it as 2.5 seconds. Okay. So here the right option is option C. Next is ruling gradient. Next is the problem for ruling gradient. If ruling gradient is 1 in 20 and there is also a horizontal curve of radius 76 meters, then the compensated gradient should be. So first we have to know the formula for compensated gradient. Compensated gradient is equal to ruling gradient minus maximum limit of grade compensation. And what is the maximum limit of grade compensation? You have to know another formula, that is 75 divided by radius of the horizontal curve. Okay, so first find out 75 divided by radius of the horizontal curve. Here they have given the radius of the horizontal curve as 76 meters. So maximum limit of grade compensation is 75 divided by 76. And then ruling gradient is ruling gradient minus maximum limit of grade compensation has to be done. Here the ruling gradient, it is given as 1 in 20, but the answer is given as in percentage. So you have to first convert it into percentage. 1 divided by 20 into 100 minus 75 divided by 76. The answer is 4%. That is option B. Fine. Next is, if the average center to center spacing of vehicles is 20 meters, then the basic capacity of a traffic lane at the speed of 50 km per hour is. So for this, the basic capacities formula we have to know. C is equal to 1000 V divided by S. Here V is the design speed. It is given as 50 kilometers per hour. And S is the stopping side distance, center to center distance between the vehicles. It is also provided. So direct substitution, basic capacity is equal to 1000 V divided by S. We have given with all the parameters, values of all the parameters, that is 1000 into 50 divided by 20. Just substitute directly and we'll get the answer as 2500. That is option C, that is 2500 vehicles per hour. Next is camber in the road is provided for Option A, effective drainage. Option B, counteracting the centrifugal force. Option C, having proper sides. Option D, so you have to choose. So you know what the camber is. We have discussed. I think you remember what the camber is. So the slope provided on either side. So the pavement for drainage purposes. We have discussed for rainfall areas, for the rainfall and all. If it is any problems will be there. So that's what is camber. So it is provided for effective drainage. And for counteracting the centrifugal force, what is provided? The counteracting the centrifugal force, they'll be provided with super elevation. Super elevation is also known as cant. So you shouldn't confuse the two words, confuse with these two words, camber and cant. They may ask what is provided for cant in the road is provided for what purpose. They may ask like that also. So always check what it is. Just be familiar with all the terms, and then only you can identify the right option here. So here the answer is option A, that is effective drainage. So that's it. And we have actually covered the most of the things which we'll be discussing in our upcoming sessions. First, the geometry characteristics, then the traffic characteristics, and then the transportation planning characteristics, and then finally the pavement materials and some of the previous year questions, the most recent previous question, and also some of the previous year questions are also discussed here. And if you have any queries, you can reach us by this phone number 770-96396 and email us at info@skillexplore.com. And our website is also provided here. The site address is www.skillexplore.com. And thank you. If you have any queries, you can ask now. Length of the course is actually according to our syllabus itself. We'll be covering almost all the portions from your syllabus. It will be like we'll be having mostly like 2 to 3 hours class for each subjects maybe. And yeah, we'll be covering the complete amount of syllabus, and also we'll be discussing our previous questions as well. And the mock test will also be there. Particular experts for each of the subjects will be handling these subjects. Yeah, it will be like 2.5 to 3 hours for each subject, maybe there. All these details will be available, and we'll be giving details. And you actually email us at info@skillexplore.com, and we will be given with more idea about the passing score and these weightages and all these things. The general idea will be provided if you are asking through info@skillexplore.com. Yes. We have covered this basic questions for traffic engineering alone. So traffic and transportation engineering courses alone. This is just the area which I am concentrated on. And I am dealing with your traffic and transportation engineering session, and maybe construction material session. So I will be dealing with these areas. So that's why I have concentrated on this area alone now. So similarly, the other records will be there. and they'll be giving you more idea about the area in which they are specialized in. I am actually doing research in traffic and transportation engineering, and that's why I have focused this. My major in MTech is geoinformatics, and currently I am specializing in traffic and transportation, actually mainly in transportation engineering area, and that's why I'll be dealing with these things, and also construction materials mostly I'll be dealing. So that's why I have covered this area, and I am more interested in this area, and also I have more knowledge in this area. That's why I have chosen. Similarly, other experts will be there, and they will be explaining you in more detailed way about the other subjects as well. Okay, I hope that you have got the general idea about the traffic and transportation engineering here, and hope satisfied.